Hey everyone, this video is for AMD GPU users that wants to run stable diffusion. So we're going to use ROCm 5.3 on Ubuntu 22.10. This also works on 22.04 and 20.04. So first a review of the specs I'm going to use. So this is my Asus G14 laptop 2022 model. So it's the 6800HS for the processor, and the GPU, it's a 8GB of VRAM GPU. It's a RX 6700HS. It's written 6650XT, but this is the wrong model. The driver reports the wrong model, but probably this is an equivalent model to the mobile one. So if you have a GPU with less VRAM, it can still work. Like 6GB of VRAM can still work. But you need to do certain things I'm going to show in the video. But obviously it's recommended to have 8GB or even 12, 16GB if you can. So let's start. First, we're going to get the AMD GPU installer. So 2210 is not officially supported, so you get the 2204 one, the jammy one. After you install the installer, by the way, all the as usual, all the instructions I'm going to put it in the description down below, so just don't worry about it, just can copy and paste. Next, we're gonna start the installation. So we're gonna install ROCm, obviously. This is necessary for most things, and also the HIP and MLlib libraries. If you want to use TensorFlow, you're gonna need these. And then the node-DKMS parameter. This is to avoid installing the kernel mode driver, because on 2210, if you install the kernel mode driver with ROCm, it's gonna break the install. Probably it's incompatible with the current kernel version. Anyway, it's not officially supported, so I didn't debug exactly why it doesn't work yet. I'm still in the process to do so, but in the meantime, you should skip the kernel mode driver installation. If you're on 22.04, you don't need this flag. You can install the kernel mode driver that comes with ROCm. Same thing for 20.04. So let's start the installation. Should be quick. Okay, it's done. Next, we're going to test ROCm SMI, equivalent of NVIDIA SMI. So you can see there are two GPUs, the integrated GPU and the main dedicated GPU. So we're going to try ROCm info. You can see we're going to get an error. So it says that it's not in the render group. So you need to add your user in the render group to be able to access some resource. So we're gonna also add our user to the video group as well. So you see that they're not added right now. You can check that with the groups command. Then we're gonna add video render, and we're gonna need to reboot afterwards. Oh, I did typo. Okay, now we're rebooted. Let's check if we're properly added to this group. Yes, video and render. Now we can test ROCm info. Seems to work. So next step is to install Ananconda, the stable-diffusion official repo. Needs a Conda environment. So we're going to install the requirements first. And download the installer. Now we're going to give the possibility to execute that script with chmod command, and start the installation of Ananconda. So you can install it in your home directory. In my case, I'm going to put it on an external hard drive, since it takes quite a lot of space. So with all the models that you would need to download if you want to try several models, several branches of stable diffusion, you can pile up quite quickly. So installing Ananconda on the external hard drive might be a good idea. So yes, answer yes to that. Okay, so we need to restart a shell. Now we're ready to sync the Stable Diffusion GitHub repo. Oh, forgot to install Git. This is a fresh install. So I rewiped my installation to make sure the steps were okay. Forgot that. Okay, so it's cloned. We cd into it. So first we're gonna create the Conda environment, and this is gonna download a bunch of stuff, as you will see. So it's pretty convenient, and also activate the environment afterwards. So that could take 5-10 minutes depending on your connection. So I accelerate the video for that. So as you can see, it installs Pytorch, but this is the wrong version of Pytorch for us. We need the ROCm version of Pytorch. So right after, we're going to install that. Okay, so you can head to pytorch.org, the main website, click install. So Linux Conda, and you see the Conda is not available for ROCm, so we're going to select it, and it's going to still work. Just copy the command, and you can surely notice it's ROCm 5.2, but that's compatible for installation of ROCm 5.3. So that's installed. So next step is to download the actual model, but you need a Hugging Face account for that before. So you head to this page, you sign up or log in, and then you can download the version 4 model. So once downloaded, we're going to make a directory called stable-diffusion v1 inside the repo, and then we're going to make a shortcut from the model you downloaded to and put it in the repo. So you can copy paste the model and rename the model if you want, but if you have many branches that use the same model because you want to try many branches, it's and you don't want to copy them all around because it's a couple of gigabytes, it's better to do that. Okay, so now we're ready to try an example. we're going to start ROCm SMI. So we can see the GPU usage and memory usage. But there's seems to be some issues with the percentage of VRAM it's reporting and the GPU usage as well. So the numbers are not, doesn't seem quite right, but still an indication. So we're going to use the example given in the stable-diffusion repo. So a photograph and an astronaut riding a horse. And we're going to set the number of samples to just one, so it's faster and also uses less VRAM. 8 GB is not that much for stable diffusion. So we're going to talk about VRAM usage a bit later. So as you can see, there's a crash. So it's because our GPU is not officially supported by ROCm, but there's other GPUs that use the same architecture that are. So we're going to override our GPU ID by using this command. So you might or might not need to do that. So the first time you run it, it's a bit longer because it needs to download a bunch of stuff. Oh, it doesn't find a model. Probably I did a mistake with... Okay, so I got the extension wrong. Now it should work. So we might get out of memory. So yeah, okay. Because, so if you get that, probably because the resolution is too high. We're going to reduce the resolution, so we're going to reduce it to 256 by 256. That said, you're going to see the quality is not that great at that resolution, not just because of the resolution itself, but it seems that it has trouble generating quality images for that low of a resolution. The quality itself is not great, as you're going to see. And after that, we're going to try with double the resolution. So I just wanted to show what type of results you're going to get with 256. Okay, so once it's generated, yeah, you can go into outputs folder and you're going to see it. So you see it's not really interesting and accurate. It's not really representing what the text prompt. So we're going to change the resolution, and also we're going to add another flag. It's called precision. So the precision flag, so we're going to put it to full. So now what's a bit complicated is that this GPU is supposed to handle half precision quite well, and it does actually, but in some cases it does not, and the full precision works better. So you might need to try this flag to see what works best for you. So in this case, setting a percentage to full is going to make this this command work and fit into memory strangely. The same for Pascal GPUs. Pascal GPUs doesn't support half precision, so you need to set this the NVIDIA GPUs. I mean, NVIDIA Pascal GPUs. You need to set this flag. So, but as you're gonna see later with another branch, we don't need to, and actually works better with the default the autocast. So the probably half precision. So I recommend trying this flag and just to see what's the result. Okay, so let's see. The images should be much higher quality on top of being higher res. So you see that's much better. So next, we're going to try other branches of Stable Diffusion. There is some forks, not other branches, but some forks of that have a considerable amount of optimizations, like Neon Secret one. But Neon Secret seems to use X-formers, and I haven't been able to make it work on ROCm, since X-formers was developed with NVIDIA GPUs in mind. So we're going to use Basu Jindal's fork, which is quite awesome, as you're going to see. So to install it's quite easy. We're going to use our current Stable Diffusion brand. We're going to use the original Stable Diffusion repo, and we're going to just drag and drop the optimized SD folder as it says in the installation instructions. So I'm going to clone. This fork. So we're gonna just drag and drop the optimized folder from this fork to the original Stable Diffusion repo. So it's much easier this way than doing all the setup. Okay, so we're going to try an example. So the cyberpunk style image of Tesla car reflection in rain. We're going to reduce the number of samples and keep the current resolution. So you see it works right off the box, and it uses much less VRAM. I think one of the optimization it has in this branch is it slices the calculation so that it only uses what it needs. So that means you can have higher resolution images. and up to for 8 GB, I managed to have it up to 1024 by 768. I try 1024 by 1024, and I get out of memory issues. Also, as you notice, we didn't set precision to full. So I'm not sure why it's this fork handles. I didn't check the code, so I don't know why it handles the mixed precision better in this case, but it works. So you see the VRAM usage is lower if you check ROCm ASMI. So now it seems to have so now it's over, so it generated in 6 minutes. As you can see, the images are quite cool, high resolution. So that's it. If you have any questions, please feel free to ask down below. Don't forget to like and subscribe. See you next time.